And now, direct from New Mexico, is Mr. Ray Breer with E-Chem. He's going to talk to us about epoxy concrete. Mr. Ray Breer.
I'm Ray Breer with E-Chem. I'm here to talk about epoxy polymer concrete. We've been producing this product commercially since about 2016. What is epoxy polymer concrete? Epoxy polymer concrete is very similar to Portland cement concrete. We have aggregates, we have sand and rock, and then instead of using cement and water, we use epoxy resin as our polymer binder for the concrete system. Today in the presentation, we're going to just do a quick overview of EPC, the construction process, advantages, some of the safety aspects of this product, specifications, and any questions. I'm also going to review some of our, we've had some FHWA funding, stick funding with this product over the last 3 years, and we're coming to some culmination of some of those projects. So EPC overlay, some of the unique characteristics of this versus other polymer concrete systems, we're 100% solids. What that really means is we have no VOC content, no hazardous air pollutants, we're non-flammable, very low odor. Since we are 100% solids, we're also moisture insensitive, which means we can go down on saturated surface dry concrete. We don't want to go down on a wet surface, but as long as it's surface dry, saturated conditions, it works very well. It's a low modulus resin. It's very flexible, it moves more in tune with the concrete surface over wide temperature variations. We have thinner applications at 3/4 inch up to full depth. Cure times are very rapid, 3 hours at 73 degrees. Actually, we're a little bit shorter than that. It's using in high stress applications, high traffic areas, a lot of impact areas. It performs well. We're waterproof, we're 0 coulombs, chloride ion transmission. Service life's 25, 30 years plus, 8 to 10 times more abrasion resistance than Portland concretes. It's very, over the life cycle cost, it is a very cost-effective solution, especially in high ADT situations. Some of the applications that we've done, whole-scale bridge deck overlays. That's either from resurfacing and reestablishing a bridge to grade corrections due to either constructability issues or roadway realignment issues. We do abutment repairs, pothole deck repairs, rut infills on roadway surfaces, where if you have a lot of studded tires or chain tires, we can actually just infill the rutted areas with a finer formulation of this product. The components, very similar to the Portland cement concretes, 60% sand, 30% coarse aggregates, and 10% liquid binder. Overlay installation process, we want to evaluate the environmental conditions. We want to make sure that when we're installing that we have the right conditions to install. It's a warm weather product, so we have to have conditions 45, 50 degrees or higher. We have to have conditions where we're not going to have rain events during the installation process. And we want to make sure we have the proper cure temperatures. We want to make sure that we're cured before we get below that 45-degree threshold. Deck preparation is going to be very similar to other deck restoration processes. We want to remove any of the deleterious concrete from the surface, prep it, have a good sound surface to go back on. Forming and equipment use, primer placement, primer pretreatment placement, mixing, placing, finishing, cleanup, and as I mentioned earlier, make sure we have the right cure time for the installation. Some of the environmental conditions, as stated, no rain events during the installation, surface SSD dry, temperature 50, and it says 100 degrees. We can go higher, but the contractor has to be in tune with his working time. All we're doing is shortening that working time that he's going to have to place and get that final finish on that deck. And making sure we have the proper cure time before we have return to traffic for the polymer concretes. So surface preparation, remove any unsound concrete, and replace with EPC. So we recommend actually doing your pothole repair and doing your restoration of that deck prior to doing your whole scale overlay. Shot blast the surface to a minimum of CSP6. We've done a number of hydro demolition projects. This product works very well with hydro demolition. We're able to actually go back same day because we are an SSD product. We don't have to wait for that deck to get below a certain moisture level before we can install the polymer concrete. We just have to make sure that we power wash any latents off and remove any of the ponding and any of the visibly wet areas, and then blow off any of the debris off that deck prior to setting up forms. So here's some typical examples of deck prep. The left there we're showing shot blaster. It's a machine that's used to shoot down steel shot. It recovers the shot, separates the dust, and provides a bondable surface. The left side is a deck pothole project. They've saw cut, chipped out, and they're just placing back the areas that need to be addressed there. We have there's the hydro demolition process. This project was in Tennessee. They actually that rebar was actually at the wearing surface before we started. That was a deck in pretty poor condition. There is audio. There we go. Sure we go. It's pretty loud. And this was a good project for that. We did have a lot of reinforcing bar at the drive surface. We didn't want to take anything off of that deck that we didn't need to, but we needed to expose the reinforcing to overlay that surface. So the surface preparation here so we have the surface ready. We're setting up the equipment and getting ready to prime the surface. The project on the right was where they constructed that bridge in two halves, and when they constructed it, they had an elevation bust. They ended up having a swale down the main driving lane of I-25. So we ended up hydro demoing that section out and removing that swale condition for that project. That was back in 2016. Some more shot blasting. So forming for placement. So there's different applications for forming. It's going to depend on the application apparatus. Screed pavers, we want to run a screed paver on plywood or some type of screed surface that's going to be uniform and provide basically it's going to be the elevation of the finished profile. Bridge deck pavers are used. They're going to install their trolley rails, and they'll set those to the required elevations for those installations. Self-propelled pavers, they run off of a guide wire, so they'll set the guide wire up at the proper elevation as that self-propelled paver goes down the deck. And it's the a lot of times when we see poor installations, it's because they don't take the time and the care to get those elevations set and correct. Even recommending doing a dry run. I know it might take a little bit, an extra hour, but it's worth the time to do a dry run with your equipment down that deck without placing anything to make sure you don't run into any hiccups as you go across. Some contractors like to use skis on their screeds, and what that does, it's a 12 to 16 foot section of straight edge they put on the edge of their screeds, but that elevation is only going to be as good as your pre-existing elevation. So I would be concerned that you have a good starting elevation prior to allowing your contractor to use the skis. So placement forming, so we have two different situations here. The project on the left, they're using a Bidwell paver. They have their trolley rails set up. One's going to be off the side rail of the bridge. The other's going to be off a temporary rail that they installed for the construction zone. The one on the right, that's a truss screed. They actually used wood placement to set their elevations on the middle of the bridge. The outside of the bridge, they use their pre-existing edge forming when that bridge is constructed. The project on the right was a elevation bust during construction. It was over a live river. Their shoring ended up notwithstanding the loads during placement. They had some pretty extreme settlement during the placement. They actually had low and high spots, 3 to 5 inches in various areas on that deck. So it was a pretty adverse elevation conditions to start with. Picture on the right is that same project in the Hems Canyon where they reestablished, where they had the shoring issues. And the one on the right, that I think that's here in North Carolina. That is here in North Carolina. So this is a smaller project in Oregon. It was a remote location. This contractor used just steel rails shimmed to the deck. This project was originally a UHPCC project, but due to the remote location of it, they didn't have the time to get the material there or the equipment on site to where they could adequately batch the material in this location. Here's a sample of using skis. So this was a new installation. This was in US 54 in New Mexico. The issue with this project, it was originally designed to have the polymer concrete overlay on it, but the placing contractor knew there was a secondary overlay, so he didn't take care to establish a good elevation during his placement process. So that was a bit of a tenuous finger pointing situation on that project. So EPC overlay priming. So a primer is a little bit of a misnomer. Epoxies inherently bond well to all conditions, but if there are cracking issues with the deck, we want to pre-treat those cracks. It's going to be a belt and suspenders position. So if there ever is an issue with the overlay, we want to protect the lower layer reinforcing. So we want to pre-treat any surface cracking in any deck. It's applied very thin film, 100 to 150 square feet per gallon, and we really want to pay attention to that surface cracking is what we're looking at. Primer is going to be open 3 to 4 hours, and it's all temperature relevant for epoxies. Some examples of the priming. Basically, it's flood coated on the deck. Use broom squeegees, rollers to move the excess across. The contractor right there and left, they're using spray systems to prime the deck. If it's really rough conditions, it's probably preferable to spray. So the overlay mixing. So we have a few different packages available. The smaller packages, 0.67 or 1.34 cubic foot, that's going to be more for the maintenance or smaller project installations. Then we have semi-bulk packaging for volumetric placement. So this is going to be a very similar truck to the modified latex vehicles. It's going to have bulk sand, bulk aggregate, and resin dispensed through a computer-controlled mixing platform. For hand mixing, we can pump hand mixing if for a larger project. The resin percent by aggregate is going to depend on the substrate and the aggregate. So 10.5 to 12.5% is kind of the sweet spot, and that's going to be liquid to aggregate by weight. This is a pump dispense system where they're hand mixing. So they're actually breaking bags into the mixer, and they're pump dispensing the liquids. This is hand mixing both liquid and the aggregates. And when we're so just because we're hand mixing doesn't mean we can't do bridges. They're just going to be a smaller scale, being very reasonable in the working times that we can work with. We've done complete bridges in single shifts by hand mixing. This is a volumetric truck application. This is modified latex suppliers equipment. They built 2 trucks for this, for the epoxy polymer concrete installations. That was here in Cumberland County, I believe, in North Carolina. Here's another volumetric truck. This is that Hemis project. Kind of gives you an idea of how it's placed. It's very similar to any topping product going on a deck. This is a truss screed that's hand cranked, hand mucked, and hand finished. This bridge was, we probably got across it, was 190 feet or so. It took us about 2 hours per side. So this, the left is another, this is the project with the skis. It's a truss screed in the skis, and the right is the Bidwell paver. And so the finishing, the EPC finishing is actually very, very similar to Portland cement finishing. It's going to be the same tools. It's very easy to hand finish and to edge finish. You know, any contractor that's done any concrete finishing, their guys can pick it up in usually an hour at the most. It's all about timing with these products. This bridge was completed in a single shift from prep to install. With smaller bridge, but it was still, you know, we had to get it done. It was so far. It was 2 hours from the closest paved road to get back in there. This is Bidwell paver. That was the North Carolina project we did 2 years ago, a little over 2 years ago now. That was with, we did 4 structures in a weekend on that project. They were all within the same interchange area. This is the North Carolina project with the Bidwell. This is a good video. So this project was a milled prep on this project. This is the automated slip form paver. They, like I said, they set up the string and they just it goes down the deck, you know, pretty quickly. Handwork, same as concrete. They're using a work bridge on the right to seal up edges, put on traction aggregate. And so for refinishing, so we can either hand tine or we can have the deck grooved. Usually we want to wait about 3 hours before we start the grooving process. But it can all be done in that same shift. And what the sand is for, it's a traction aggregate. We get a little flow to that resin. We don't want to introduce a slick driving surface. We want to make sure we maintain our coefficient of friction that's required, you know, on these decks when we're finished. This was a project we finished a little over a year ago. It was it was a segmental bridge, US 54, Canadian River Bridge in Logan, New Mexico. This was won the ASBI Award of Excellence on this project. So even though it's in the middle of Logan, New Mexico, most people will never go over it. This is about an 80% heavy truck bridge. And it's US 54. So US 54 runs from New Mexico pretty much all the way up to Chicago. It's a very heavily traveled secondary route for semi-trucks. I mentioned, so we're under a couple of stick grants right now. We're towards the end of a stick grant in PA. This was their ECMS 4941 project. So the initial scope was to determine the suitability of the use of our EPC overlay in Pennsylvania in lieu of polyester polymer concrete. And at any point, if we had a fail, they would just end the study and end the grant. So the initial issues were consideration was placement, mix design. If there was any issues with that in other states, they actually contacted 8 other DOTs that had used this product. We got through that round. They did a comparison between our product polyester and the durability. They found it comparable. They developed test methods. They hired consulting engineers to identify what testing is appropriate to this product. They developed an installation practice guide as to what the appropriate installation aspects of this of the EPC overlay are at this point. And then finally, if we got past all that, we finished the draft of the initial specification. That's completed, and we're going through we have all our material in for testing right now. We got the specification back 2 weeks ago. We submitted our material to PennDOT. They're going to test it internally, and then we have a round of third-party testing that they're requiring. So that should be completed within the next 3 weeks. We had another stick grant this year. This is through Idaho DOT through the LTAP. The issues there, they wanted to demonstrate some innovative products for use by local agencies. So we went in there. We did a demonstration, a scaled demonstration project. It was a smaller structure, able to do it in 2 days. And one of the days we brought out the local agencies, and they actually were able to get hands-on and get dirty doing the install out there. It was a pretty neat use of the stick funding through the LTAP in that area. So at the end of it, we did the hands-on demonstration, and we're providing technical data and installation guidance for the local agencies as they need. Here's a few pictures from that installation. So EPC overlay has been in use since 2016. We've been in 14 states. We're probably going to add 4 more states this year with that. Excellent durability. Said we've been under the stick evaluation. We're also in a high ADT evaluation by Caltrans. We completed the low ADT evaluation last year, moved to high ADT structures, so that it's bidding this year and will be installed next year on I-5 in California. And we have a few new products with this coming out. We're using some higher density aggregates for testing, and so we're reformulating for some thinner applications on this product. And that's the end of my presentation.
Questions for Ray?
Good presentation.
Thank you.
Is there a 3-hour strength version of EPC?
As a 3-hour strength as far as where we're at.
Yeah.
So we're going to be around that. It depends on temperature. So at 73 degrees, kind of the benchmark is going to be about 2,800 psi. So that's really the benchmark. And so if we're talking, so if it's a nice sunshiny day and it's a deck at 73 degrees, that deck's really 85 to 90 degrees. And so we'll be at that. We'll be there in about an hour and a half. If it's 55 degrees, it'll probably be about 6 hours. So it's really, for every 10 degrees, either we're cutting in half the cure time or we're doubling it. So it's kind of that rule of thumb. And the more mass, so this is an exothermic product, the more mass that we're putting down, it's going to create its own heat to cure as well. So it's really dependent on thickness and the conditions that we're placing in.
Hey Ray, that was a great presentation. But could you expand a little bit on the VOCs and the safety when you're installing your product?
Yeah, so there's other polymer resin concrete products on the market, and we recognize if we're going to develop something, we had to make it better in performance, bonding, and eliminate the health issues associated with the other products. So everyone says, well, VOCs, we all know what VOCs are, right? So volatile organic compounds are unhealthy for the systemic, for mammals. The other issues are it creates ground level ozone, and ground level ozone it contributes to the warming of in these areas, especially in the central urban areas where they're heavily used. So we eliminate that. And HAP, so HAP is kind of an acronym that's been developed by the EPA, and it sounds pretty innocuous, but it stands for hazardous air pollutant. All right, that doesn't sound too bad. What's not hazardous in the air if it's a pollutant? But the real issue is it's either a cancer-causing or thought to be a cancer-causing product. So and that's the real issue. So and we've eliminated those issues out of this product, to where you don't have to wear a respirator, you don't have to hire an industrial hygienist to come in and do a site evaluation. This is, we've been vetted and tested and deemed, those hazards have been eliminated.
Okay, thanks, Ray.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.